And you can do the same thing with tan, cosecant, secant to see whether or not they're even or odd. I've done the first two, and they're all listed on the handout. Now, why bring this in? This is no problem here, guys. Let me point out though on the side here, where I leave it. So if you're asked to find cosine, negative pi over 9. What's that equivalent to? Cosine is just pi over 9, since cosine has been identified as even. You guys agree? If I accept that definition for even? Okay, now, with that said, and we can close this down, part 2, I would like to sketch this. F of x is equal to, now you'll have one like this, I'm doing like this, this one coming up, you'll have one like this, definitely on that last exam. I brought one in, yeah, it's cute. I don't think we've done this one before. Negative 2 cosine 2x subtract pi plus 3. I don't think we've done this one. Okay? Now I'd like to, I'm leaving it up to you, like to either do it through transformations or use that technique I showed you last time, I think, and we'll call it bounding. Guys, if I did it through transformations, please help me out. This would tell me to do what? Reflect the graph through the x-axis. The 2 says do a vertical stretch by a factor of 2. You're talking about mess. Down here, you have to clean this up a little bit, simplify it. And to simplify that, guys, I could rewrite this by taking out a factor of what, 2? And that would leave me this, which adds more transformations. The 2 would tell me to do what? Horizontal shrink, maybe by a factor of 1/2, 1 over 1/2. We did all these transformations. There's the phase shift. They call it the phase shift. I've been calling it a horizontal shift. A horizontal shift to the right, what? Pi over 2. So if we hear the words phase shift, horizontal shift. And finally what? Plus 3, a vertical shift up. I don't have the time to do all those transformations, but I guarantee you, if you were patient and you did each one, it will work. I'm more concerned about to get the graph fairly quickly, and that MATH2 instructor wants you to do it quickly, because they want you to do some calculus on this afterwards. You guys will do it quickly. We're going to do this. On the parent cosine graph, did I graph the parent cosine graph earlier? Yes. Can someone reflect back to the parent cosine graph, which looks something like this? I'll just do it real quickly. Let's see if you guys agree. So 0, what was it, pi over 2? Pi, all this from the unit circle. 3 pi over 2, and 2 pi. Please remind me to start at 1. Drops down to 0. Negative 1. Back to 0. And back up to 1. And the 1 cycle looks like that. I'm going to ask you to draw one cycle of this crazy graph up here. Just one cycle. Why not draw it with the same bounds I did on the parent graph? Just bound it the same way I did this one cycle there. Now, if you're clever and you want to do another cycle, you can pick up and say, wait, Professor, after 2 pi, could I not say what the next one is, and name the numbers for you, and draw another cycle, and use that for your cycle. I think this right here would be the best cycle to be used here. You say, what are you going to do, Professor? I'm going to take this and force it to fall between, just like my parent graph did, fall between 0 and 2 pi. Just like the parent did. That's the extent of the cycle. So guys, I'm going to have this to fall between, right like this. They call that the argument inside there. I'm going to force this to fall between 0 and 2 pi, because that's where my one cycle fell. Make sense? So you got to realize what particular cycle you're going to look at, see how it's bounded, and try to bound your graph the same way. Now, that said, I'm going to solve that inequality. Guys, divide by 2, I'm up here, 0. And that's an equal to x subtract pi over 2 less than or equal to pi. What would be my next step to get the x completely by itself? Add pi over 2 to everything. And I'll get this if I make no mistake. By the way, guys, this becomes 3 pi over 2, I think. Now, guess what I've done? Based on my parent graph, pi over 2 is going to act as my initial, like 0 was here. On the end, 3 pi over 2 on this graph I'm seeking, 3 pi over 2 is going to act as the end. So I've got the beginning, the initial, and the end. Do I have some points in between I need to find though? Yes. To finish this up. So when I get all this together, try to get a graph done, let's see what this might look like. I had to do this before I go back into chapter 6 and get chapter 6 started here shortly. Okay, guys, the initial, pi over 2. The end, 3 pi over 2. Now, someone remind me, how do we find the 3 intervening points? Because I need 3, just like my cycle there, in between. I think I asked you guys first to find the period of the graph. So take the ending, subtract the beginning of that cycle, and that will tell you the period of the graph as a function. So I subtract these two guys, and we end up with, I think, pi. Help me out. Is that pi? How many quadrants am I covering? 4. 1, 2, 3, 4 all together on my cycle. Is it true? Do I cover 4 quadrants? So it makes sense now to take that period, divide it by 4, and this is sort of, I'll put a comma here, this is my spacing number. I will space my grid by pi over 4. So we'll start at pi over 2, go down to 3 pi over 2, but I want to space by pi over 4. Guys, since I'm spacing by pi over 4, let's do this. Let's call this 2 pi over 4 rather than pi over 2. Let's get a 4 in there. And maybe call this one what, 6? Help me out. Over 4, yes or no? And it's going to be much easier now to start adding pi over 4 to get the spacing. So if I go back to the initial, add pi over 4 to 2 pi over 4, that's going to take me up to 3 pi over 4. Add another 2 pi over 4, what is that, 5 pi? Over 4, isn't it?
It wouldn't be 4 pi.
Where was it? We're adding pi over 4. 4 pi over 4. Then 5 pi over 4. And finally, do I reach 6 pi over 4? Yeah. And now I have all I need, 1, 2, 3, 4, 5, like the parent. 1, 2, 3, 4, 5 on this one. Making sense? The way we're doing it? Now, with all that done, Alexandra, this can be confusing, but be careful here, guys. You've got to practice for this. I am now going to erase this. I've taken care of this. This is gone. You need not worry about this any longer. The way we approached it. I took care of it. In this new method, without going through all this transformation. What am I left with though? I'm left with this, and this. And then I'll get the graph. Guys, I would suggest you get that vertical shift out of the way first. A vertical shift of how much? 3. So I'm going to go up 3 and show, back to short like this, roughly. So up here, this is my new axis. This is not a horizontal asymptote. That's just my new axis. And my graph cosine is supposed to be what? Flipped over, is that true? Turn upside down, and then stretched by what? 2. Let's get the stretch out of the way. I've vertically shifted up 3, but I need to stretch 2 more. If I stretch 2 more, will that take me up to 5? And if I go down 2, what's that? Well, down to a 1? Okay, that's there, ready for me. Guys, now I need to think what cosine parent graph looks like. It's this one. But my graph is upside down. Takes this shape, but it's flipped over the x-axis. So please tell me at the beginning, what was it, 2 pi over 4? Where should my upside down cosine graph start? 1. Love it. 3 pi over 4 on the axis. 4 pi over 4, 5. 5 pi over 4, back on the axis. 6 pi over 4, and we're back down to 1. And this is a rough sketch of one cycle of that, I'll get some erasing here, of that function. Marked, that's it. It's the cosine graph upside down. Is it true? Is it making sense the way we present this, guys? So do a little thinking, do some practice during the holiday. I'll get that handout to you so you can see some practice problems here shortly. That one's done. Now I need to identify the period of this graph. The amplitude there is 1. Domain and range. Okay. Guys, the period I think we said earlier was what, pi over 4? Was it? No, it's pi. Pi. I'm in the wrong place here. Pi over 4. The spacing is pi over 4. So it's pi. Amplitude? 2. And I think your textbook points out the amplitude can always be identified by the number stuck out front. I'll tell you what the amplitude is. Amplitude is always positive. Domain, I just have one cycle. You know you have, what, infinite number of cycles? So the domain would be all real numbers. And the range on this graph? 1 to 5. Now that is a beautiful example there. Done without all those transformations. Make sense? Now I will ask you on the exam, after you get the graph done, this is just sort of like a little check. I'm going to ask you to find maybe an f of, for this function, then I'll choose one for you. Let's try, guys, let's try maybe 3 pi over 4. Let's try to find algebraically f of 3 pi over 4. Ignacio, if this graph is correct, I hope it's correct. The graph says at 3 pi over 4, I'm looking at where? 3. I had better get a 3 when I do it algebraically. Let's see if I do. I'll put a question mark there. F of 3 pi over 4, let's go back, guys. I erased some of this in all my talking here. -2 cosine, someone remind me what this was inside here. 2x minus pi. And was there a plus 3?
Yeah.
So I need to go back here, guys, and algebraically replace that x by 3 pi over 4. Here goes. So this is going to be equal to -2 cosine. Put this in 3 pi over 4. It says subtract pi, doesn't it? And I could make this what? Pi is what? 4 pi over 4? You guys with me? And plus 3. Make sure I did all that correctly. That look good or not?
We have to multiply by 2, right?
And got what? 2 here. Is that true? Now, I'll say pi here. Let's go ahead and put pi. What's pi? What's that? 4 pi over 4. Okay, -2 cosine. Inside there, 2 cancels into 4. Does that become 3 pi over 2? I think. Subtract pi. Plus 3. Or this becomes now what? -2 cosine. Guys, inside there, using a common denominator of 2, is it really pi over 2? If you put these two together. Is that pi over 2? Is that true? Now, from the unit circle, what on earth is the value for cosine, which is the x-coordinate, of that pi over 2? 0. So this says now you have -2 from the unit circle, this is 0, plus 3. Do I end up with 3? And is that what the graph told me earlier? So it checks. And in fact, all those points should check. Now that's going to be about 30 minutes. Look at it. Right? Okay. then you're gonna have one like this to practice with, or in fact have on the exam. Now, let me do this though, part 3. I have not yet, and I'm gonna do it now. Remind me, I don't think I've sketched yet the parent graph for tangent. Okay, so I'm gonna do it now. Get it out of the way. So let's call this f of x is equal to tan x. Guys, here goes. You want to unwrap that unit circle. We're going to do it fairly quickly. You can see what this shape may look like for tangent for a parent graph. Okay, that's 0, pi over 2, pi, 3 pi over 2, 2 pi. Is it true? Those came from the unit circle. Now I'm doing tangent. What's the definition for tangent? Y over x. Here we go. So you will not confuse that x staring at me in the black there. I'm going to use theta instead. Your textbook likes to use x there. I'm going to use theta. But tangent is y over x. Anyone tell me from the unit circle at 0, if you place the y over the x at the very beginning of the unit circle, you're going to end up with what answer? I think we're going to end up 0. So remind me right quickly, what were the coordinates at the very beginning? 1, 0. So if you place the 0 over 1, y over x, you get 0. What happens up at pi over 2, where the coordinates are 0, 1? That is undefined. That means there's going to be a vertical asymptote to show this does not exist. Now go over to pi. I think pi had coordinates what? -1, 0. Place y over x, you end up with 0. Go down to 3 pi over 2 of 0, -1. So you're placing -1 over 0. Another what? Undefined. And finally 2 pi, you make one complete revolution, you're right back. Well, that's what it looks like right now. This is a parent graph for tangent. Let's do it by quadrants. Remind me in quadrant 1, guys, this interval represents quadrant 1. What is tangent as a value? Is it positive or negative if you're in quadrant 1? Positive. Yeah, everything's positive in quadrant 1. That says your graph you're seeking, looking for, must be in quadrant 1. I have no choice. It's got to be above the x-axis. It's got to follow that asymptote. Now when I go to quadrant 2, between 90 and 180, someone remind me if you're in quadrant 2, y over x, tangent is? Negative. It says the next piece should be below. I have no choice. You guys agree? Now next interval, this is quadrant 3, between 180 and 270. If you're in quadrant 3, you're placing y over x, you're placing a negative over a negative, which turns into a positive, which means the next piece should be above. And if you want one more piece, quadrant 4, you'll find that to be also what? Negative? That means the next piece would look something like that. Can anyone tell me, just out of curiosity, what would be the next point if I should extend the graph for some reason? What would be the next critical point out here to work with? 5 pi over 2. Anyone tell me, just out of curiosity, what do you think is happening at 5 pi over 2 if I should extend the graph? Another undefined, another asymptote. You could say, Professor, I know what's going to happen, so we'll just do that again. You guys agree? Just out of curiosity, suppose you move to the left. Negative pi over 2. And you're doing tangent, y over x. What do you think is happening there? Well, at negative pi over 2, is it undefined again? Is there another asymptote here? Yes or no, guys?
Yes.
Okay. And I would assume the way the graph looks, maybe it's going to do this again? What do you guys think? Now, we're talking about cycles. Now we just hold you responsible for one cycle. This one, the way it worked out for us, I have already 3 cycles. You said, Professor, which of those 3 should I know for your class? I'm going to ask you to remember this one that's caught between these 2. If I ask you to graph something with tangent, and Ignacio says, Professor, I did mine using pi over 2 to 3 pi over 2, I have to accept it. Another student, Alexandra, may say, no, Professor, I like 3 pi over 2 to 5 pi over 2. That's also another cycle. And she may use those for her bounds in graphing. That's fine. I like this one for a reason coming up in chapter 6, though. Okay, guys? With me? Now let's list the domain, range, that's the parent graph. I have 3 cycles. Now here, let's get the domain out of the way first. Now this is tricky. You guys show me that x cannot be, hang on. In this case, pi over 2, I'll list it. It cannot be 3 pi over 2, these are vertical asymptotes, 5 pi over 2, so forth and so on. You need to come up with a formula that would give me all of them, because these cycles go forever. That's the part where you may have a little difficulty. Because you want to think they have a formula that would give me these numbers. So I can put it right here, and we'll put pi over 2 on the side here already. I need something like a formula, because all these have pi over 2 in them. What do you think that formula might be?
Plus
And we'll try it. Then after I show you what it is, they will accept it. Anyone think they know what it is? Alex?
Parentheses 2n minus 1 pi over 2.
Okay, now you're saying 2n minus 1. Here goes. Alex, I'm going to test it. And n should be an integer. We know what that means. So let me just pull out an integer right quickly, 0. If I replace n by 0 in his formula, the term drops out here, I get what, -1? In fact, I end up with negative pi over 2. Was there short enough an asymptote at negative pi over 2? Now suppose I replace in his formula n by 1. If I replace n by 1, guys, I think I end up with what, 1 inside there? 1 pi over 2. And was there an asymptote at pi over 2? Alex, thank you. Now, therefore, if I replace n by your formula, 10. If I do 10, that's 20 subtract 1, what is that, 19? That's 19 pi over 2. Would you expect, way down here at 19 pi over 2, another asymptote?
Yes.
Yes. After you get the formula to us. Did anyone have any idea of another formula? I've seen different formulas. Shane?
Pi over 2 plus n pi.
Oh, hang on. X cannot be pi over 2 plus how much?
N pi.
N pi, where again, n is an element of the integers. She says, Professor, I'm going to write mine like that. Watch what happens. I'm going to replace n by 0. If I replace n by 0, guys, this term drops out. And she's left with pi over 2. Was there an asymptote of pi over 2? I tried 0. Let's try 1. If I replace n by 1 here, I get pi. Pi plus pi over 2, I think it's 3 pi over 2. Was there an asymptote there? So it's, the formula she just gave me also gives me asymptotes. Is that true? So I could also use that. I think, Shane, if you played around with this, maybe take out a factor of pi over 2 here in your answer. I love that though, I'll give you credit for it. If you should factor out pi over 2 in your answer, Shane, I'm going to have 1 here, oh boy, plus, guys help me out here. What would you have over on the end if it's going to work? Maybe, hang on.
2n.
So if I use the distributive property here on your answer, Shane, it would be pi over 2 times 1, pi over 2. This times this, 2's cancel, you get pi n. Are those two saying the same thing? So that's another way to express your answer. Absolutely. So guys, we got the domain out of the way. Range, easily done. Is it true? Amplitude, none. There's no highest point on this graph. Period, Well, you gotta decide which cycle first, and I told you I like this cycle for a reason first. If I use this cycle, then the ending of that cycle was pi over 2. Subtract the beginning, negative pi over 2. Guys, I think you end up with, when you do the math there, pi. So the period of the tan graph is pi. So every pi units, it repeats. Woo! Nazio.
Is the pi over 2 times 1 plus 2n equal to 2 minus 1?
Well,
I
where?
mean, 2n minus 1 times pi over 2?
Are you talking about hers?
Yeah, because that
Shane?
one has a positive and the other one has a negative.
Ah, beautiful. Guess what? Neither one will work.
Okay.
Alex, you gave me the 2n minus 1. It works. Then all of a sudden, what Shane gave me, and I played around with it, I see a 2n plus 1. You say, Professor, I thought it was a minus. His works, and this one's going to work.
Okay.
So go for it. It will tell you the locations of those asymptotes. And I'm sure there's other formulas out there that'll work. Ah, good observation. Yeah.
A question for tests. When writing the domain, if we're using n, do we have to use those symbols to say n is an integer?
Yeah, because if you don't say n's an integer, someone may think you can go here and replace n by 3/4, 5/6, 2/3. And replace that n only by an integer, no fractions, no decimals. So I need that. Okay. Guys, anything else there? Now, thank goodness I did that. Where am I? Part 3, I think. Oh, part 4. Now we're back to where we should be. Now, did I give an opportunity Monday to do something with inverse sign
Yes.
or not? I think I did. Did we show how to chop the graph off and make it 1-to-1? To make it have an inverse. We did all that business. Did we get the domain of the inverse listed in the range of the inverse? I hope we did. Okay, we'll do one more here, guys, today. And that is, I'd like to take this function, cosine, find its inverse. Let's find that function's inverse. We did it with sine. First, most importantly for us to get a start, is cosine a 1-to-1 function?
No.
And if I graph it right quickly, which I will, and a student was asking about this after class on Monday, let me remind you what the regular cosine graph looks like. 2 pi, starts at 1, drops down to a -1, and guys, please help me to start here. Drops down to 0, -1, 0, back up to 1. And my graph, one cycle, looks something like this. Now, this is cosine. This one, guys? And why is it not 1-to-1? It does not pass the horizontal line test. Okay? So you gotta make it 1-to-1. Well, only 1-to-1 functions have inverses, and they're asking for an inverse. Guys, here's what the committee did, not Ramsey, not SMC. Scientists, mathematicians got together worldwide, said, okay, we need to work with this in some manner, but we can't work with it right now because it's not 1-to-1. So they made it 1-to-1. Now, can anyone tell me, remind me Monday, how did they make sine 1-to-1? How did they chop it off? I think from negative pi over 2 over to what? Positive pi over 2, and that made it 1-to-1. Cosine, they did a little differently. They did this. Is that little slice 1-to-1? Tell me, though, also one reason they chose this little slice. Does that little slice still have the maximum value on the cosine graph there, which is 1? Does it also retain the minimum? Okay, it does, so that's where they sliced it off, and now passes the horizontal line test, and therefore this little slice will be what we'll be working with to find this inverse. Since I'm looking at it, the domain of this little slice, guys help me out here, is it from 0 to pi?
Yes.
And the range of this little slice is -1 up to 1. Now on the side, which is fairly done quickly here, can someone tell me the domain of the inverse? Let me write like this. And the range of the inverse based on what we know about domain and range. What should the domain of the inverse cosine be? Equivalent to the range. So it should be what? -1 to 1 bracket. Range? 0 to pi. Inclusive. Now this is where we have some issues. That's true there though, for cosine. Now on the side here, let's try just a few problems here, move along with this. Number 1, Alexandra. All of a sudden you see inverse cosine 1/2. You say, Professor, I don't know what that means. What are you asking for? I see the inverse notation, the little minus sign there. What does that mean? That means now you're looking for the angle whose cosine is -1/2, or +1/2 in this case. So here's the translation. There's an angle out there whose cosine is 1/2. And you gotta find it. Ooh, can anyone remind me on the unit circle, where have you seen cosine, which is the x-coordinate, equal to a 1/2? I think I heard someone say it.
60 degrees.
60 or pi over 3? Okay, pi over 3. And I think there's a possibility of another one. Where cosine, the x-coordinate is,
5/3.
I heard 5 pi over 3. You're in quadrant 4. You guys agree? I can't have two answers. That's why students ask me after class about this 1-to-1. I can't have two. I'm supposed to have 1-to-1 here. So guys, which of these two am I to accept, even though both work? It all depends on this restriction they gave me. Yeah, which one falls between 0 and pi? Pi over 3. So this one's out. And the only answer you'll see is 60 degrees or pi over 3. Just based on this condition here. Restriction. Number 2, is up here. You're asked to find inverse cosine -1/2. So be careful. -1/2. Translation, it says where or what angle, when you take its cosine, you get a -1/2. Well, let's think about the unit circle the way it looks right now, just leading me into my discussion. Where on that unit circle have you seen the x-coordinate cosine equal to a -1/2 to begin with? 2 pi over 3, I think is one of the possibilities. And I think there's another possibility like where? 4 pi? Is that true? Now, that's where I remember. I think those are the two. I remember. Restriction, your answer must fall between these. To make it 1-to-1, just like the graph over here. That's 120 degrees, 2 pi over 3 if you wish, 120. Does 120 fall between 0 and pi? Does it?
Yes.
Oh, yeah.
Oh, that's good.
I-
Does 120 fall between? If so, I've got the answer. By the way, guys, this one is equivalent to, if you want to change it, help me out here. How much is this? This 240? Help me out.
Yes.
240?
Yeah.
Is it 240? Yeah. Gee. Does 240 fall in between these two? No. So the answer is 2 pi over 3. So if it fits that restriction, that's all you're looking for these inverses. Restrictions, restrictions, restrictions. Even though you say, right, Professor, I found another one on the unit circle that works. Yeah, but it's got to fall within this, or you cannot use it. With me, guys? Okay. So that's inverse cosine out of the way. Okay, part 5. We'll get this done. Beautiful. Now I'd like to take this one. Another inverse. This is the last one I'll be doing. take f of x is equal to tan x. To find its inverse. Now the reminder, like we've done earlier, to find the inverse, first we check to see whether it's 1 to 1. Is that true? And then we have to find the inverse. Now I will do this. You'll say, Professor, I remember finding the inverse. We always did this. We interchanged the coordinates. Remember doing that? I think I pointed this out on Monday. And you try to solve for y, guys, you can't solve for y in this. You can't divide through by tan. Just tan of what? So this is true, but you can't find y. But I look for the inverse. Okay, guys. Geez. I think a good way to do this. Except it's inverse tan. If I just sketched, and I think I erased it, I sure did. Did I just sketch the parent graph or tangent?
That's right.
Okay. Now, I'm going to use, oh boy, here it goes. Here we go. Yes. On the grid for that parent graph, please tell me if I should accept this cycle that you saw just a few minutes ago, like this, and this. Did I have a cycle, remind me please, that looks something like this? Was that one cycle? I think, in fact, I think I've had 3 cycles. So I'm going to use this one. Guys, they use this one for the inverse. If I use this, the domain on this little slice, this one little cycle, is that domain from negative pi over 2 up to pi over 2. Range on this little slice, or this little cycle here, is negative infinity through infinity. Now tell me, based on what you see there, what should the domain of the inverse be? In other words, inverse tan. What should that be? Negative infinity through positive infinity. And the range on the inverse, absolutely, negative pi over 2 up to, not including, up to positive pi over 2. You guys agree? So there's inverse tan with its domain and range listed. Now you said, Professor, is there an inverse for secant? There is. Is there an inverse for cosecant? There is. And is there an inverse for cotangent? There is. I'm not going to do it myself. It's listed in your textbook if you should want to use it. I'm going to do the 3 principal ones. Yeah.
So, because there's no reason for, there's no way for us to find the y, is that why we're not actually graphing the inverse?
Exactly. Beautiful, beautiful. Hang on. Ignacio, don't walk out of here and tell a Math 7 instructor. Ramsey showed me this, and then this is a graph of inverse cosine. This is not the graph of inverse cosine. What is this? This is a slice of the cosine graph. This right here is not the graph of inverse tangent. What is it? It's one cycle of the tan graph. I am not. Do they have graphs, the inverses? They do, and I have a handout with them on there. Okay, they do have graphs, but I didn't graph the inverses. Guys, make sense? Now, based on this, let's try just a few of these to close this down so I can move on. If you're asked to find this, tan, where am I? Yeah, inverse tan of 1. Now you got to think in your mind, what's he asked me to find? I'm asking you to find, hopefully from that unit circle, the spot on there, the angle at which tan is 1. Where you place y over x, you get 1. Where is it? 5 over 4, 45 degrees. And by the way, the coordinates on the unit circle at 5 over 4, I think were a radical 2 over 2 and a radical 2 over 2. You put one over the other, you get 1, which is y over x, that's tangent. Now, may I use it? Well, we said, the answer has to fall between these two. Does, 45 degrees fall between negative 90 and a positive 90? Yes. So I can accept it, it's done. If I saw this, gotta be careful. Inverse tan, negative 1. First, let's get at those directly on the unit circle first. Where have you seen y over x that would give you a negative 1 from the unit circle? At what spots? When you place y over x, you get a negative 1.
3, 5, 4.
Do it again?
3, 5,
3, 5, or 4? I'll take, and I think there's another one.
5.
Negative 1. When you place y over x, I think you get a positive 1 for you down in quadrant 3. I think it's in quadrant 4. What size is it? 7, 5, and 4, thank you. Now, Billy, with all that said, I've got two possibilities. I can't have two. Let's go down to 1. 1 to 1. That's 135 degrees if you wish. 135. Does 135 fall between negative 90 and a positive 90? No. This one, I'm doing it in degrees, is 315 degrees. Does 315 fall between negative 90 and a positive 90?
No.
No. Therefore, he's saying, Professor, there's no answer. There's an answer. Alex, what do you think it is?
Negative power 4.
Now he says, Professor, I think it might be here, this. Is that tricky? Now, let's take a look at the one 315, for example. 7 pi over 4. Guys, it is here in quadrant 4 with a reference angle of 45 degrees or pi over 4. Is that true? That's 315. I think it's 315, was it? Was it 315 we said earlier? Now, could I rename that 315 and say, could I not move in this direction, clockwise, and stop the same place? So could I call it negative 45 degrees, or negative pi over 4? Which is equivalent to what? The other way around, 315. Make sense? And why must I call it negative pi over 4? To make it fit this restriction. That's the trouble on these inverses. You'll come up with an answer that looks like it should be correct, but if it does not fit this restriction, we can't accept it. Okay, guys, any concerns about this? The inverse? So I've done inverse sine, inverse cosine, inverse tangent. Is that true? Woo! Okay. I'm looking at my clock here. Here we go. Now watch carefully. Yeah. Part 6. Shane, do me a favor, you're so organized. There was a handout I think I gave the class, not today,
Yesterday.
last time, and I'm trying to find whether I even have a copy myself.
The 6.1.
Yeah, 6.1 and 6.2. 6.1 and 6.2. Okay. Now, everyone should have a copy of this. We got a copy of this, I'm sure. Mr. Parker, I think you even sent this out to the class, right? Yeah. Shane, on 6.1, 6.2, on the handout. Okay, what we're gonna do is just a few of these, and then close this down. Please tell me, number 1 was asking the class to find what is an inverse sine of what?
1/2.
Thank you, now hold on. Now, inverse sine will place right quickly the restriction. The restriction for inverse sine, we did that I think on Monday. The answer must fall between, and guys, see if I'm right. Must it fall between these two? Now, does anyone recognize directly from the unit circle where is sine equal to of 1/2 to begin with? 5 or 6, 30 degrees, and I think there's another spot, just out of curiosity. Is it 5, 5 or 6? Where the y coordinate is 1/2? Now, if I'm able to use one of those, I'm finished. So guys, it's like 30 degrees. This 30 degrees fall between -90 and a +90. We're done. That's out. So the answer is 5 or 6. Finished. Shane, tell me what, find one that with a cosine in it for me, please.
Inverse cosine of negative root 2 over 2.
Nice. Guys, I'll quickly remind you, inverse cosine is with this, I think I did that today. Our restriction was between what, 0 and pi. Is that true? Now, first tell me though, where have you seen this on the unit circle? That's a negative. 3 pi over 4 Nalcio, and I think there's another spot. 5 pi over 4?
Yeah.
Now, if one of those works, we're done. This is like 135 degrees, if you wish. Does 135 fall between 0 and 180?
Yes.
We're done. This is out, this is the answer. Nice. Shane, give me one more.
Are you okay with the tangent?
Yeah, I like that, yeah.
Okay, inverse tangent of negative root 3 over 3.
Oh, that's nice. A reminder, inverse tan, I think I just did it. Restrictions, gotta fall between negative pi over 2, not including, and pi over 2. Now guys, first tell me, this one's a little tricky. Where on the unit circle, if I place y over x, are you guaranteed you're going to end up with a radical 3 over 3, in fact, negative radical 3 over 3?
5, 5, or 6.
Okay, I'm hearing 5, 5, or 6, now hang on. If I'm correct, 5, 5, or 6, if you check that unit circle, had coordinates of, help me out here, radical 3 over 2. That's true, guys? And was it a 1/2? So if I place y over x, I'm doing this. Clean that up, rationalize. Does that take me to where I want to go? Except I want negative. So I'm in the wrong quadrant. It's not 5, 5, or 6, is it?
I think that is correct.
Oh, is it? Okay.
Yeah, the
Okay.
negative, was it negative radical 3?
Well, it's negative here,
Yeah,
Yeah.
and therefore negative here.
yeah.
If it is, and we've discovered it already, we think it is, I heard, what was it, 5, 5, or 6? Guys, that's, what, 150? Is that 150?
Yep.
Okay, does that fall between negative 90 and positive 90?
No.
All right, that's what I was thinking. It doesn't work, does it? After all that work. Oh, well, we're gonna have to find it. Besides 5, 5, or 6, which came close, is there another one on the unit circle that maybe I could test? That's your guarantee when you place y over x, you do get negative radical 3 over 3? 11 pi over 6. Let's see, hang on. 11 pi over 6, help me out here, was that this? Whoa, yeah. And a negative 1/2.
Yeah.
So if I place y over x, will I get a negative radical 3 over 3? Is that true?
Yes.
Take a close look. Mr. Parker, you're gonna check something for me here shortly. Now, you tell me at 11, 5, or 6, do I have my coordinates listed correctly?
Yes.
This and this? If I place y over x, do I get cleaned up this?
Mhm.
If I do, it's 11, 5, or 6. It's supposed to fall between these two. It doesn't. what is 11 pi over 6? 330? Is that 330 degrees?
Yeah.
That's 330 even though it works. Does it fall between negative 90 and a positive 90? Darn it. So what am I going to do? You're saying, Professor, rewrite what Ignacio just gave you. He gave you 330 degrees, go backwards, negative 30, negative 5 or 6, and now that would definitely fall between these two. Isn't that tricky? You gotta make sure it falls between those restricted intervals. Now, Shane, before we take this break here coming up, number 4.
Yep, inverse cosine of 2.
Now, the reason I put that there, we all get all into this, and we start discussing this, inverse cosine of 2. Have you seen on the unit circle any place where the x-coordinate has a value of 2? Never. Might you see it being equal to a 2 somewhere? No. In other words, this one's undefined. No answer. Now, before I leave it, Shane, can anyone remind me what the domain was? Oh, did I do domain on the inverse cosine? Did I do the inverse cosine today or not?
We did.
We did. What was the domain on, where is it? It's gonna fall between negative 1 and a positive 1. I give you a what? 2 doesn't fall between negative 1 and positive 1 by the restriction on the domain. That tells me also this is impossible, undefined. And that can happen. Now, before we take the break, here's where I wanted to get to today, which I did. After all this, then we'll take a break here. Oh my goodness, where are we? Is this part 6 already?
Yeah.
Part 7. Now, Shane, if I remember the worksheet correctly, go down to the next part and see what they're asking me to do down there.
Find the exact value of a given expression.
Okay, here we go, and the first one looks like what?
Sine of inverse cosine of 1/2.
This is almost like a composite. Now, inside there, guys, inverse cosine 1/2, I hope we recognize that right quickly, because I think this one can be discovered on the unit circle. Where on the unit circle have you seen the x-coordinate, which is cosine, equal to a 1/2? Pi over 3? Was it pi over 3? I heard of pi over 6. Was it pi over 3?
Wait, for cosine?
For cosine. Cosine's equal to a 1/2.
Oh, it'll be
Yeah,
pi
yeah,
over
yeah.
3.
Oh, don't scare me.
Yeah.
Is it pi over 3?
Yeah, it is.
Yeah. Huh. And then Shane says, don't stop there, Ramsey. And now it says do this to it. Now take the sine of it. And what's the sine of pi over 3 or sine of 60 degrees? Help me out, guys.
You're right, 3 over 2.
That's the answer they're looking for. Did we do that correctly? Mr. Park, I was going to ask you to check something here shortly for me. Shane, we'll take a break here shortly. Tell me one more, and I'm looking at my handout also. That might be interesting. Hang on just a second, since I have it right here in front of me. Let's do number 2. Read that to me, Shane.
Secant of the inverse tangent of root 3.
Now, maybe I can find this one directly on the unit circle. Does anyone think they know where y over x, which is tangent, will give me radical 3? Here we get pi over 3 or pi over 6? Pi over 3? Hang on now. So you think this might be pi over 3? A little reminder, guys, on the unit circle, the coordinates at pi over 3, help me out, was it 1/2 and radical 3 over 2? So if I place y over x, what do I get radical 3? Yes or no? If I place this over this and cleaned up, what do I get radical 3? Okay, looks good. Now can I say, well, professor, inside here is pi over 3. And would that fit? I erased the inverse tan. No, right here it is. Coming out should fall between these two. Guys, is this okay here? Is this 60 degrees? Does that fall between these two for inverse tan? Got you, so I can accept that, but you're not finished. Now it says, please take the secant of that. And what is secant by definition? 1 over x. And we said the x coordinate was what? 1/2? That is so cute. The answer's 2. Mr. Park, do me a favor and check that one. Take secant of inverse tan, radical 3, and see if the final answer is 2. He's writing a program. Are you writing a program?
It's
Coding
2.
over there. Is it 2?
Yeah.
Okay. Okay. Last one, then we'll take a break, guys. Number 3. Jane? This is
Tangent.
the last one, tangent.
Of the inverse sine of 1/3.
Now, this is where it gets interesting. Before the break. It's gonna get interesting. First, before we close down with this last problem, it says, where on the unit circle have you seen the sine, which is y, equal to a 1/3? You haven't. I've never seen a 1/3. Have you, do you recall a 1/3 or a y coordinate sine? No. Alexander, before the break, we got troubles. This means this. And they want me to find the tangent of it. I don't know what it is. I'm not gonna take the tangent of it when I don't know what it is. Does anyone know what it is? Now I could ask Mr. Park to write a program right quickly. He's writing programs for me. He could tell us, go ahead and tell the class what inverse sine of 1/3 really is. And do it in degrees. I don't know myself.
It's like 19.5.
Is 19.5 one of those on the unit circle? That we should know, is it listed? Like 30, 45, 60? Have you ever seen a 19.5? I haven't either. So we got some big issues here to close out for the break. Guys, and they're asking to find tan of it. Now, if I accept his 19.5, then he just merely takes the tan of that and you can tell what the answer is. But you have no calculators to use, so how on earth are you gonna find 19.5? I didn't know it was 19.5 myself. You was the old professor, I'm gonna fail this class. My summer class is full already. I don't have any room for anyone else. Okay, here it goes, and then we'll close this down. Guys, the best I can do here on one that I do not recognize is this. We're gonna sketch it. Watch carefully. Watch carefully. We're closing down with this. Guys, I'm gonna sketch the angle. Mr. Parks already helped us out. He says, Professor, it's 19.5. But 19.5 is in quadrant 1. So if I want to sketch the angle, I'm gonna place it in quadrant 1 and do something so cute. say it looks something like this. And guys, let's call this 19.5. No. That's what Mr. Parker gave me. All I know is the sine is 1/3. But I know where it's located, it's in quadrant 1. Sine is 1/3. And they're asking me, please take the tangent of it. Up here goes. Someone's going to ask me some relationship. You have a quiz tonight. Does someone recognize an identity of some sort? Sine squared plus cosine squared. Secant is equal to 1 over cosine. 1 plus tan squared is equal to secant squared. Does anyone have an idea with what you see on the board now? Something I could use in terms of an identity and use it and maybe give me a start. Now, I know sine is equal to 1/3. Now, could I use that information with an identity and maybe sort of help me out? And which identity would you want to use?
Sine squared plus
Love it. This class is something else. Sine squared plus cosine squared equals 1. And since they gave me sine is 1/3, put that in here. Equals 1. Guys, when I clean this up, I think that's 1/9. And when I subtract it, I think it's 8/9. And then do a square root. And since I'm in quadrant 1, I know it's going to be what? 2 radical 2 over what? 3. 3 positive. Now, I know the cosine. Is that enough now to find, they want me to find tangent. So could I now say, hold on, Professor, I know tangent, if that's what they're asking to find, is equivalent to what? Sine over what? Cosine. They gave me sine, 1/3. I just discovered cosine, 2 radical 2 over 3. If I clean this up, guys, the 3's are going to cancel. Rationalize. Does anyone see the final answer there?
Root 2 over 4.
It is root 2 over Alexander, tell me again.
Over
4.
4.
Mr. Parker, before we take a break, you gave me 19.5 if we were using the calculator for the size of this angle. Would you now please find the tan of it and see what the tan of it is approximately equal to?
Tan of what?
Tan of, where was it? 19.5.
Okay. It's like 0.354.
0.35 something?
Yeah.
Give me another digit. 35 what?
4.
4. Now, Mr. Park, we got this answer. Would you approximate this? What is radical 2 divided by 4? Close to.
I'm sorry, I keep messing up with the keyboard part, so I'm like. Put a negative.
Square root 2 divided by 4.
Yeah. It's same.
What is this again?
Yeah, it's
0 point what? 354?
0.3535.
Rounds up.
Yeah.
So it checks. What are you doing? Writing programs?
Sorry.
Okay. Okay, guys, you're going to take your 10-minute break. I'm going to see you at what is that? 6:30. Okay.